Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Unit 4, Lesson 3. The lesson is called Angle, Bisector, and Proportional Parts. In this lesson, we are going to learn what is the meaning of angle bisector, and the difference between interior bisector and external bisector and the relation between them. Let's start the lesson. First, we are going to talk about the internal bisector. Okay, we have a triangle ABC and AD is an interior bisector. The bisector is a straight line or ray bisect the angle or divide the angle into two parts. So AD here is called interior bisector or internal bisector. Okay, the internal bisector divide the base BC into two parts like this, okay, DB and DC. The ratio between the two parts comes from the bisector DB and DC equal the ratio between the two other sides BA and AC like this. DB over DC, DB over DC, DB nearer to AB. So I will start with AB like this equal AB over AC. So DB over DC equal BA or AB over AC. Okay, each part corresponding to its nearer. DB opposite to AB because it is next to it, and DC adjacent to its AC or opposite to AC like this. Okay, now let's talk about the external bisector. Okay, also if we have triangle ABC like this and we draw the external bisector of angle A, the external bisector comes outside the angle like this. Okay, this is the external bisector or the bisector of the exterior angle. Okay, the exterior bisector intersect BC ray here at this point D. So AD is called the external bisector or bisect angle CAB externally. So it is divide BC like this, from D to B and from D to C. This is called external bisector, DB and DC. The two parts DB and DC are proportional with BA and AC. Again, DB over DC equal BA over AC like this. DB over DC equal AB over AC. Okay, short with near, long with far. Again, here AB nearer to D and AB far to D. So the short part corresponding with the near to the point of the intersection or point of division, and the long part corresponding with the far part AC. So DB DC equal AB over AC. And the theorem said the bisector of the interior or exterior angle of a triangle at any vertex divide the opposite base of triangle internally or externally into two parts. The ratio between their lengths equal the length of the other two sides of the triangle. Okay, this point D called the point of division but internally, and here D is called the point of division but externally. Okay, let's start the first question with us. In the opposite figure, find the value of x. Okay, here AD bisects angle A internally. So DB DC equal DB opposite to AB, so it is AB AC. Notes that D repeated 2 times and A repeated 2 times. D and A are the 2 points of the outer points of the line segment or the ray of division. Okay, so DB over DC equal AB over AC. So DB equals 8, DC equal 10, AB equal 12, AC equals 4x minus 1. So 4x minus 1 equal 12 times 10 over 8, which is equals 15. By sending 1 plus, so 4x equals 15 plus 1, 16. By send 4 divided, therefore x equal 16 divided by 4 equals 4, so x equals 4. Now D is the point of division of the line segment AC. So DA over DC equals AB over BC. DA equals 5, DC x plus 1, AB 8, BC x plus 4. So cross multiplication, 8 times x equals 8x, 8 times 1 equal positive 8, 5 times x equal 5x, 5 times 4 equal positive 20. Send 5x to the left side and 8 to the right side. So 8x minus 5x equals 20 minus 8. So 3x equals 12. So x equal 12 divided by 3 equals 4. So x equals 4. Number 3. Now AD is external bisector of angle EAC. So DC over DB equal AC over AB. Substitution. DC equals 15, DB equals 20, AC 9, AB equal 5x plus 2, so 5x plus 2 equals 9 times 20 over 15 equals 12. Okay. Excuse me, it's 5x plus 2. So 5x equals 12 minus 2 equals 10. And send 5, so x equal 10 divided by 5 equals 2. Okay, the next question, number 4. AD is internal bisector, so DC over DB equal AC over AB. Again, 5x over 6x. Okay, 9x plus 2 over 10x plus 4. Cross multiplication. 9 times 6 equals 54 x power of 2. 6x times 2 equal positive 12 x equal 5 times 10 equals 50 x power of 2, and 5x times 4 positive 20x. Collect x power of 2 and x, so it will be 54 x power of 2 plus 12x minus 50 x power of 2 minus 20 x equal 0. I send this the right side to the left side, so it will be 0. 54 minus 50 equals 5, excuse me, it's 4, and 12x minus 20 negative 8 x equal to 0. Now I'm going to take 4x common factor, so 4x open bracket, because 4 and 8 in table 4, and so I make divide 4x. 4 divided by 4 1, x power of 2 divided by x equals x, negative 8 divided by 4 equals negative 2, and the x over x cancelled. This is equal to 0. Now 4x equals 0, so x equals 0, and x minus 2 equals 0, so x equal 2. Of course this is refused, and this is the value of x, so x equal 2. Now number 5. In this question we have here right angle triangle. Okay, remember when we have right angle triangle, okay, so actually you are going to use Pythagoras Theorem. Okay, now this part, before finding this part, so I need to find CD. Okay, CD equals what? Equal square root 50 power of 2 minus 30 power of 2 equals 40. So CD equals 40. Okay, when BC equal x, so this one is called 40 minus x, so BD equal 40 minus x, because x plus 40 minus x equals 40. Okay, now x over 40 minus x equal 50 over 30. X over 40 minus x, 40 minus x equals 50 over 30 by making the cross multiplication. So 30 times x equal 30x equal 50 times 40 equals 2000, and 50 times negative x equal negative 50x. Send 50x to the right, to the left side, so 30x plus 50x equals 2000. Now 80x equals 2000. By sending 80 as a divided, so x equals 2000 divided by 80 equals 25, so x equals 25. Now number 6. Here E is a point of division, so EC over EB equal AC over AB. Again, EC over EB equals AC over AB. So 12 over 16 equals 9 over x plus 5. So x plus 5 equals 9 times 16 over 12, which is equal 12. By send 5 minus, so x equal 12 minus 5 equals 7. Okay, now let's study some important remarks. The first remark with us. If we have triangle ABC and AD is the external bisector and AE is the internal bisector. Okay, first, by looking to this angle is a straight angle. Straight means 180. I divided this angle into two dots and two stars. So 2 dots plus 2 stars equal 180. Again, 2 dots plus 2 stars equals 180. If I take 1 dot plus 1 star, so I take the half of 180 equals 90. So this angle equals 90 degrees. So the angle between the internal bisector and the external bisector is 90, or we can say that the internal bisector and the external bisector are perpendicular. So if AE bisect angle CAB internally and AD bisects angle CAB externally, so AE and AD are perpendicular and the measure of the angle EAD equal 90 degrees. It's a very important remark. The internal and the external bisectors are perpendicular. Now, another remark number 2. If we have isosceles triangle ABC and I draw the internal and the external bisectors like this, AB isosceles triangle, AE is the internal bisector, AD is the external bisector. And as I said in the previous remark, that the internal and the external bisector are perpendicular. Okay. Before in the second prep, we studied that in the isosceles triangle, the bisector of the vertex angle is perpendicular to the base. So this angle equals 90 and this angle equals 90. So we have here 180 U shape included 180 or two supplementary angles. That means AD and BC are parallel to each other. Okay, so AD and BC are parallel. Now I can say that in the isosceles triangle, the external bisector of the vertex angle is parallel to the base. Again, in the isosceles triangle, the external bisector of the vertex angle is parallel to the base. Now let's solve the next question. Now number 7. Okay, in this question we have here triangle ABC. This is the main triangle ABC. Okay, in this triangle AD bisect angle A internally and AD perpendicular to AE, so AE is the external bisector. Again, so AE is the external bisector of angle A because they are perpendicular. Okay. Now I need what? I need X. So I'm going to use the external bisector EC over EB equal AC over AB. So again EC over EB equals AC over AB. Okay, here X plus 1 over X plus 1 plus 9, so it is X plus 10 equals 6 over 12. Make cross multiplication, so 12x plus 12 Okay, before completing this okay, here AD is the internal bisector and AD perpendicular to AE, so AE is the external bisector, okay, according to what I said in the previous remark. So AE is the external bisector. Okay, first I need to find CD and BD to help me to find X. Now, number 7, AD is the internal bisector and AD perpendicular to AE, so AE is the external bisector. Again, so AE is the external bisector of angle A. Okay, from this we can find that EC over EB equals AC over AB. Again, AC over AB equals EC over EB. Therefore, 6 over 12 equals X plus 1 over EB equals X plus 1 plus 9. X plus 1 plus 9 equal X plus 10. Okay, making a cross multiplication, 12 times X equal 12X, 12 times 1 equal positive 12, equal 6 times X, 6X, plus 6 times 10 equals 60. Okay, I'm going to collect X in the left side and the numbers in the right side. So 12 X minus 6X equals 60 minus 12. 12 minus 6 equals 6X equals 60 minus 12 equals 48. And then divided by 6, therefore X equal 48 divided by 6 equals 8. So X equal 8. Okay, now the next now this is example 2 in the opposite figure. ABCD quadrilateral, draw AX, bisect angle ABD and intersect BD at X, XY parallel to BC, prove that DY over DYC equal AD over AB. Okay, now here by using the previous lesson, DY YX parallel to BC, so DY over YC equals DX over XB. So since XY parallel to BC, therefore DY over YC equals dx over xb and this is relation number 1. Now in triangle ABD, since AX bisects angle AX bisects angle A, so dx or xd over xb equal AD over AB. Therefore, dx over xb equal AD over AB, and this is number 2. Okay, by looking to 1 and 2, we get that dx over xb is a common ratio, dx over xb and dx over xb equal from 1 and 2. Therefore, from 1 and 2, dy over yc equal AD over AB. This is the required that he asked me. Okay. Now example 3. In this example, AE over EB equal 2 to 3, as we see in the example, in the figure. AD equals 6, DC equals 9 centimeters. Prove that XE parallel to BC. This looks like the previous question. Okay, now I'm going to start with the triangle ADC. In triangle ADC, since dx bisects angle ADC, therefore, okay, here this is the internal bisector. So XA over XC equal AD over DC. Therefore, XA over XC equals AD over DC. Therefore, XA over XC equal 6 over 9 equals 2 over 3. So this is 2 and this is 3. It's very clear that AX over XC equal 2 over 3 and AE over EB equal 2 over 3. So XE parallel to BC. Okay. Now in triangle ABC, since AE over EB equals AX over XC equals 2 over 3. Therefore, XE parallel to BC. The next question, example 4. In this example, AD is a median, BX bisects angle D and angle ADB, and DY bisects angle ADC. Prove that XY parallel to BC. Okay, here by looking to triangle ADB, since dx bisects angle ADB internally, therefore AX over XB equal AD over DB. Again, since this is the internal bisector, so AX over XB equal AD over DB. Okay. Okay, now in the other triangle, in triangle ADC, since dy bisects angle ADC, therefore AY over YC equals AD over CD. Again, this is the internal bisector, so AY over YC equals AD over CD. Okay, by looking to this ratio AD over DB and this ratio AD over CD, here the numerator is AD, the denominator is BD and CD. Again, BD and CD. Look here, BD and CD also are equal. So since BD equal to CD, so those two ratio AD over CD and AD over BD are equal, therefore AX over XB equal AY over YC. Therefore AX over XB equals AY over YC. AX over XB equal AY over YC. Therefore XY parallel to BC. The next question. Now this is the remark number 3. Let we have triangle ABC and AE is the internal bisector. Okay, now if I need to find the length of the internal bisector, so it is equal square root the two sides AC times AB minus the two segments BD times DC, like this. AD is a bisect angle CAB internally, so AD equal AB times AC minus BD times DC. Okay, the external bisector, if we have triangle ABC and AE is the internal bisector of angle A, so to find the length of AE, so it is equal square root EB minus times AC minus AB times AC under square root. Okay, it is equal EB times EC minus AB times AC. This is a very important rule to find the internal and the external bisectors. Let's solve the next question. Now we have example 5. In this example, as we see, ABC triangle AB 15, AC 9, and AD bisect angle BAC, DC equal 6. Find the length of AD. To find the length of AD, so I need the length of BD. So I'm going to call BD X. Okay, now since AD bisect angle A, therefore DB over DC equals DB over DC equal AB over AC. So X over 6 equals 15 over 9. Therefore X equals 15 times 6 over 9 equals 10. So here dB equals 10. Okay, therefore AD equal square root the two big parts minus the two small parts. 15 times 9 minus 6 times 10. Okay, it's equal 8.66 by using the calculator. The next question. ABC triangle. AB equal 8, AC equal 4, BC equal 6. First, I'm going to draw the triangle, and I'm going to call it ABC. Where 8, AB equal 8, AC equals 4, and BC equals 6. Okay. Now AD bisects angle A and intersect BC at D. So from A I'm going to draw a ray like this, and this point is called D. Okay, now I'm going to draw AE bisect the exterior angle at A. So I'm going to draw the exterior angle at A like this, and draw the perpendicular, the bisector of this angle. This is the internal bisector, and this is the external bisector. So intersect BC at E like this. This is E. So AD is the internal bisector and AC is external bisector. Okay. Find the length of DE, and find the length of AD and AE. Okay. First, I'm going to call this one X. So this one is 6 minus X. Okay, since AD bisects angle A internally, therefore X over 6 minus X equals 4 over 8. Again, X over 6 minus X equal 4 over 8. So by making a cross multiplication, 8X equal 4 times 6 24 minus 4 times X, 4X. Send the 4 to the right side, to the left side, so 8X plus 4 x equal 24, so 12x equals 24, so x equals 2. Okay, so CD equals 2 and BD equal 2, 6 minus 2, 4. Okay, therefore BD equals 4 centimeters. Okay, now I need to find EC to help me to find AD and AE. Okay, now EC over EB equals AC over AB, since AE bisects angle A externally therefore EC over EB equals 4 over 8, AC over AB. Okay, let AC equals Y, so this is will be Y over, and this is will be Y plus 6. Y plus 6 equals 4 over 8, and so I will make a cross multiplication from this cross multiplication. So Y equals 6, and so this line equal 6. Okay, therefore if this line equals 6, if Y equals 6, so ED equal 6 plus 2 equals 8. Okay, now the last part, I'm going to solve it here in this position. Now I need to find AD. AD equal square root AB times AC minus CD times DB. So it is 8 times 4 minus 2 times 4. It is equal 4.9. And AE equals square root EC times EB minus CA times AB. So it is AC equals 6 times EB equals 12 minus 4 times 8. So it is equal 6.3. The next question. Okay, now prove that EF parallel to BC. Prove that EF parallel to EC. Okay, here since CE bisects angle ACB internally, therefore AE over EB equals AC over BC. So it is equal 12 over 6 equal 2. So AE equal double AE. This is 2 and this is 1. Okay. Now, since AF over FC equals 8 over 4 equals 2 also, therefore AE over AB equal 2 and AF over FC equal 2, therefore AE over EB equals AF over FC, therefore EF parallel to BC. Again, AE over EB equal 2 over 1 and AF over FC equal 2 over 1, so EF parallel to BC. Now in this example we have AB equal AD, AB equals AD, DB equal DC. Prove that EF parallel to BC. Okay, to make it easy I will call DB X, so CD also X, and AB Y, so AD also Y. Okay, now since I am going to start in triangle ABD, since BE bisects angle B internally, therefore AE over ED, AE over ED equal AB over BD over BD equals Y over X. Okay, and a triangle ADC, since DF bisects angle ADC also internally, therefore AF over FC equals AF over FC equals AD over DC equals also Y over X, because this is Y and this is X. This ratio AE over ED equal Y over X, AF over FC equal Y over X. I'm going to call this one equation 1, equation 2 from 1 and 2, therefore AE over ED equals AF over FC, therefore EF parallel to CD. Now example 9. This example AB equal AC and BD is a tangent to the circle. We knew before that the tangent of the circle makes an angle with a chord called angle of tangency. This angle equal the inscribed angle subtended by the arc AB. Okay, so angle DBA equal angle C. And this triangle ABC is an isosceles triangle, so angle C equal to angle B. So by looking to this, we find that BA is a bisector for angle DBC. Okay, now he need to prove that DB times BA equal DA times BC. Okay, DB times DA times BA equal DA times BC. Okay, since BD is a tangent, therefore measure of angle DBA equal to measure of angle C, and since AB equal to AC, therefore measure of angle C equal to measure of angle ABC. Therefore measure of angle ABD equal to measure of angle ABC. Therefore AB bisect angle BAC DAC. Okay, therefore I'm going to use the rule of the division, okay, because these two line segments depend on the rule of the division. So BD over BC, BD over BC equals DA over AC. Okay, now here we have AC and AB are equal, so I'm going to replace AC with AB. Therefore the ratio again will be like this: BD over BC equals DA over BA or AB. Okay, AB, excuse me. Okay, now by making a cross multiplication, so BD times AB equals DA times BC, and this is the required we need, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.